Hi everybody, welcome to Unit 5. I'm very sorry that I cannot be with you here today, but I want to have us just keep on going. We can talk about this stuff when I get back, but I want to start by introducing you to Unit 5, giving you your Unit 5 phenomenon, which we can totally talk more about when I get back, because it's going to be a little interesting, I hope. But just to give you a heads up for what you're going to do, this is your Unit 5 notes packet. You can see your learning goals up at the top, just like always, space for your do nows. The thing that's different about your Unit 5 notes packet is you're actually going to get a couple of reference tables here that are built into your packet for you. These we're going to make a heavy use of in this class, but these are like smaller versions of the reference tables that you're going to have in class. I'll introduce these to you when I get back. But you'll always have access to these on every single assessment, your unit test, your final, all of that kind of stuff. I'll show you the ones we're going to use. They'll be in your table buckets when I get back. So what we're going to start with today is your Unit 5 phenomenon. So you're going to fill in this phenomenon guide as I kind of talk you through some like pictures and videos of what I would have done for you if I were, if I were present in the lab with you on this day. But you're going to walk through the phenomenon guide, pause the video as much as you need to, kind of like stop, draw your pictures, ask your questions here. But essentially, I'm going to have you record initial observations, write down some questions with the people at your table, construct an initial explanation for what you think might be happening, and then decide, is this a physical or chemical change? How do you know? Then we're going to stop on the phenomenon guide at this point, and you're going to fill out the rest of this page later as we've learned more about this phenomenon throughout the unit. So first thing we're going to do is record some initial observations about what's going on. So let me talk you through your initial phenomenon. Play, present. Okay. So your Unit 5 phenomenon is based entirely around this little piece of metal here. That is a piece of magnesium ribbon. So magnesium has been pounded down into this ribbon format here, and as you can see, I curly-cued it. So it's very flexible, it's malleable, it's shiny, and it's silver. That blackish stuff that you see is not the magnesium. That's just some other material that happens to be on there, and it shouldn't be, because metals can change their properties after they're exposed to air for a little bit of time. So just the shiny silver part of it, that's the magnesium part. So what I did was I placed it inside this little chemistry baking dish. It's called a crucible. You can see it on the scale. You can see the mass on a scale. This is something you might want to write down as one of your initial observations, is the initial mass of this system. So I curly-cued it. I placed it inside this crucible. That mass includes the crucible and the magnesium itself. I'll show you a crucible when I get back, but it's just a cute little baking dish, and you'll see it in the video on the next slide. So here's what I did with it. I took the magnesium and I decided I was going to burn it. So let me show you the video of what I did. Here's your initial mass again. Okay, so I lit our Bunsen burner. I put it underneath the crucible. So that crucible is sitting inside a little O-ring right there. And then inside the O-ring is a clay triangle. That's holding all the pieces together. And then I took some forceps and I carefully lifted off the lid of the crucible every so often. But I let this thing sit and cook for about like 35 minutes. So this is clearly a sped up video of what's going on. So you can see as I open up the lid there's a bright flash of light, right? So that's something that I want to record during. Keep letting it sit, let it sit for a while. Like I said, I think this is like 30 or 35 minutes. Lift up my lid one more time, put it back down. I feel like I probably should have put the SpongeBob meme in there. 15 minutes later. Okay, so here's where it gets interesting. I took it off. You can see what it looks like after I've let it go, after I've burned it. And note its final mass. So take a look at the original mass, take a look at the final mass. Is what you expected to happen? So this is your initial phenomenon. Magnesium's properties have changed after being heated. It's brittle, it's powdery, it's white. What happened to the mass itself? So I want you to think about this now, and you're going to go ahead and go back to your phenomenon guide, model in before, during, and after. What does this look like to you? What happened to it? And you're going to write down some questions you have that you're going to share with me when I get back. So try to make one of them investigative, meaning like, is there something you could change about this system to like investigate further? What other information might you want to know that might help you out? Try to make one of them about energy or matter. We've been talking a lot about energy, a lot about matter this entire class. I mean, we have to. Chemistry is the study of matter and its interactions, right? So try to make one of them about that. And then lastly, you can just do a simple I wonder. This is the easiest one. The only question you cannot ask is I wonder why it changed in mass. That's the question we all have, right? Get creative. What else can you come up with? After you've asked your questions, share them with your table groups. Then you're going to come up with an initial explanation together. What do you think might have happened to cause the system to behave this way? Finally, tell me, do you think it's physical or chemical? How do you know? You got to pull all your knowledge back all the way from Unit 1. What? Okay, that's all I have for you for the initial phenomenon. Work on these, then you're going to move on to the next section of your assignment. Bye!